All right, where are we at here? I need to switch back over to here. Okay, so we're gonna start on this problem here, which is a Mandelbrot set thing. Okay. Performance analysis on quad-core CPU. Bummer, because mine is AVX 512, and I have a lot of cores. Was it cat proc CPU info grep core? Core ID. I have 16 cores. If I run btop, it shows, yep, 16. No, it's hyper-threaded, so it shows 32. How does SMT hyper-threading show up in Linux proc CPU info? Processor, not core, when I say processor. Interesting. Yeah, that makes sense, because here, core ID, we enumerate up to 16 cores and then another 16. Okay, that makes sense. So I have 16 cores, two-way SMT, 512 AVX, 512 SIMD, which is 16 wide, 32-bit SIMD. Should be 16 times 32, which is 512. So it's not exactly reflective of the quad core CPU that they're talking about here. Let's go ahead and just vim up the README here. I'd rather read the README. Oh, AR64? This would be ARM. Okay, we're going to do the non-ARM one, because I don't have ARM. Well, I do have an ARM machine next to me here, but I don't want to do that right now. Okay. It's not formatted very well, and the images don't show up, so maybe I should read it from here. Okay. The assignment is intended to help you develop, let me do this, an understanding for the two primary forms of parallel execution present in modern multi-core CPU. SIMD execution with a single processing core, parallel execution using multiple cores. You'll see the effects of Intel hyperthreading as well. You'll also gain experience measuring and reasoning about the performance of parallel programs, a challenging but important skill you'll use throughout this class. This assignment involves only a small amount of programming, but a lot of analysis. Environment setup. You'll need to run code on the new myth machines for this assignment. Host names for these machines are so-and-so. If for some reason you do not have a home directory on the myth machines, submit a help SU ticket here. These machines contain 4-core, 4.2 gigahertz Intel Core i7 processors, although dynamic frequency scaling can take them to 4.5 gigahertz when the chip decides it is useful and possible to do so. Each core in the processor supports 2 hardware threads. Intel calls this hyperthreading. And the cores can execute AVX2 vector instructions, which describe simultaneous execution of the same 8-wide SIMD operation on a vector of 8 single precision values. For the curious, a complete specification of the CPU can be found at so-and-so. I'm curious just to look at it. Oh, it's just specs. Yeah, okay. Okay. Spec sheet. Students that want to dig deeper might enjoy this write-up. Just check that out. Oh, interesting. It's that URL. Let's check this out here. Okay. Looks like that's dead. But we had some stuff in 2025 here. So let's take a look. 4.3 forbidden. Maybe at the beginning of March. Nope. Maybe back here. There we go. Wiki chip. I've never heard of that. Wiki chip. MRC forms. (2002). No way I was 2002. Oh, he joined 2002. Okay, 25. Okay. What the hell is this website? I thought it was for architectures, but doing MRC stuff. Like, what the hell is this? Maybe if I go here? I don't know. Yeah. Plenty of scrapes here. Forbidden. Okay, you want it sends it to here. So we'll do this. This is 2023. It looks like it's mainly CPUs, and I mean SoCs. I guess you consider CPUs SoCs nowadays, right? Tesla full self-driving SoC, interesting. I really like this website. I wish it wasn't down. um, so the Apple A1, A2, all those. What about M1s, M2? Intel, AMD, Ampere. Don't know them. Qualcomm, Snapdragons. I know them. Samsung. I don't know their microarchitecture here. So those are chips. These are architectures. Intel, ARM, AMD. Let's see what they say here. This is all MRC crap. Just coincidence that he also had MRC's crap on there. What is this one? Fuse, wikichip.org. Let's ask Google what happened to the wikichip.org website. See if AI answers. Something about Hacker News here. Semi-wiki. It's more of an industry wiki than it is technology wiki. Okay, I don't want to get too deep here. The dollar means cash. Okay, this is the core. So you have your front end, which has an instruction cache and instruction TLB right next to each other. Micro-op cache tag, instruction cache tag. 6 bytes per cycle. 16 bytes, sorry, per cycle. Five-way decode. Micro-ops go into the execution engine. They call them EUs here, but I've heard them called functional units. These are execution units. So these are your SIMD vector. So you have 3 functional units, or 3 different ports with functional units or execution units that have vectors, vector operations. These are for multiplications, these are for ALUs. There's the memory subsystem. So that's where the data cache is. Data TL. Oh, there's data TLB? What is the difference between the data TLB and the instruction TLB? Okay. Makes sense. And then there's a unified STLB. Did AI tell me about that? No, it didn't. They're not the L3 cache here. They're not the main memory. Interesting. It's a really cool website. Let's go maybe to a, yeah, what was it? Wiki chip here. So they're having some Nginx issues. Okay, here we go. Do they have anything interesting? Sure. Just Zen 3. And that was 2026? January 3rd. Okay, that's new. Wouldn't Apple be the most popular ARM? Okay, let's go back here until we can find this page. There we go. So AMD marketing materials. They don't have die shots because these are the architecture pages. Although I'm more interested in the architecture, I do like looking at die shots to see like physical layout of all these components. Like it makes it a little bit more concrete in my head. No die shots there. I like how they divide it into client and server. See, this one had die shots. This is an architecture one that had die shots and, wow, this one just forwarding constantly. Why can't I go back further? Yeah, so maybe Intel just provides better documentation for their architectures. Let's check something a little bit more newer, maybe Ice Lake. Yeah, they don't have much there. Maybe Ice Lake on the client. Yeah, the client pages have a lot of documentation. I think this is probably from Intel. Alright, enough die shots. Now, for grading purposes, we expect you to report on the performance of code run in the Stanford Myth machines. However, for kicks, you may also want to run the programs in this assignment on your own machine. You'll first need to install the Intel SPMD program compile, ISPC. Pacman ISPC. Sorry. Yeah. Sudo okay, let's get that installed. Feel free to include your findings from running code on other machines in your report as well. Just be very clear what your machine you're running on. To get started, ISPC needs to compile many of the programs used in this assignment. ISPC can be easily installed on the Myth machines using the following steps. I don't need to do that. I can just run. Oh, what happened here? Failed retrieving. Let's ask AI what the deal is with that. What does SYY do? Man, Pacman, sync, Y. Dash Y. Refresh. Download the first copy of the master package database from the servers defined in so-and-so. This should typically be used each time you use sys upgrade or you passing to refresh or Y flags will force a refresh of all package databases even if they appear to be up to date. Okay. Well, that worked. ISPC. Cool. Grep for ISPC. It's probably like a make file somewhere, right? Oh, they're using CPP. Yeah, you got some make files in there. Let's go under prog1 Mandelbrot. Threads. Make file here. ISPC. So I guess it isn't used here. If I do the rip grep again, yeah. So maybe prog2. Prog3. Sorry, 3. There we go. Now we're in the ISPC area. ISPC flags. So down here, say grab every header file. Wait a minute, what? I've never seen that before. That generates two targets in the same target. I've never seen that before. I didn't know you could do that. Clearly I haven't read enough make files in my life. Alright, well. Let's just run make here. Looks like it worked. Sorry, make. Yep. So SPC is working. I thought this was the repo, yeah. Okay, great. Program 1, parallel fractal generation using threads, 20 points. Build and run the code in prog1 Mandelbrot threads. Prog1 Mandelbrot threads. We got some problems here. Let's do another make. Let's get that. So function memset was not declared. So if we do man on memset, it looks like it's in string.h. So we'll go into main dot, but this is CPP. I think you can just do a pound include, right? String.h, vim main.cpp, string.h, make. And then in this other CPP file, we got exit, was not declared in the scope, man exit. Oh, it even gives you the pound include here. Okay. Mandelbrot thread. Put that up here. C standard lib. Oh, my phone's blowing up again. Because it's 8 o'clock. I'm supposed to go to bed now. Well, I did get it built, which is nice. What did it build? Obj? No, I got Mandelbrot. Mandelbrot. Output from threads is not matched, so I probably have some work to do. If I do SHA-256 sum Mandelbrot star.ppm, yeah, they're different. If I do a Wayland open on Mandelbrot serial, sorry, it just opened. We're supposed to be able to see. We'll just ask AI here real quick. Hey, look at that. Let me zoom in. I think I might have broken my computer here. Let's kill that. Let's do thread. Yeah, this one's dead. No information there. Okay. So the threading is broken. So it's part of my job to fix it. Okay. remember going through this at one point. I got hung up on learning about the Mandelbrot set. Your job is to parallelize the computation of the images using standard thread. Start a code that spawns one additional thread is provided in the function Mandelbrot thread located in Mandelbrot thread CPP. In this function, the main application thread creates another additional thread using the constructor standard thread function args. It waits for this thread to complete by calling join on the thread object. Currently, the launch thread does not do any computation and returns immediately. You should add code to worker thread start function to accomplish this task. You will need to make sure that any other standard thread API calls, you will not need to make use of any other calls. Okay. Could have sworn I've done this whole thing already. Let's do Mandelbrot thread CPP. Wait a minute, cycle timer not found. If I cat out makefile. Boom, 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 boom. Dot common include obj. Okay. Common is going to have our cycle timer.h. So if I go and say vim.clingd, give me a .clingd file that includes /common files. There we go. Vim Mandelbrot thread jobs foreground, right? Thread. Okay. All right, what's going on here? Okay, we got worker thread start. Mandelbrot serial is external. Where else is it being called? It's supposed to be called here. But I'm gonna log off here. I need to get to bed, but we'll pick up on this tomorrow. I have this strange feeling that I've done this already because I'm pretty sure I worked on these things last year, but apparently I never committed or I lost all my progress on it. So, yeah, we'll get through this tomorrow then. Cool. All right. See you later.